always the denominator to a probability if you're making the fraction, right? Number 4, if the probability is 0, then it's an impossible event. If the probability is 1, it's a certain or a guaranteed. Either one, certain or guaranteed event. Number 8, you were matching 3, 1, 4, 2. 3, 1, 4, 2. If you don't know Roman numerals, 3 I's, 1 I, an I and a V, and 2 I's. Learn your Roman numerals. Okay, number 20, they went ahead and just listed them all out and said, well, 3 coins, what are all the different ways you could have at least 2 heads? And they figured out, well, how many ways total? 2 times 2 times 2. There are 2 ways to land on the first, if you were to do the fundamental counting principle with blanks. 2 ways to land on the first, 2 ways to land on the second, 2 ways to land on the third. 2 times 2 times 2 is 8. That's the sample space. But how many have at least 2 heads? Well, all 3, or the first 2, or the second 2, or the outside 2. There's only 4 out of those 8. I don't know, it just said lab-grown meat, and it was an ad, and I got annoyed, so I deleted it. 4 over 8 is 1 over 2, 1/2. Number 44, you guys had to put together some information. Now, they showed factorials, which, guys, for the test tomorrow, did I say you need to know factorial formulas? Yes. Yeah, not that you have to write them every single time, but if in a question there says something like, write out the formula 2, blank, what do I expect you to do? Write out the formula 2. Will you lose points if you don't, or if you do it incorrectly? Yes, even if you get the correct multiple choice, yes. But could you have done NCR in your calculator as well? Yes. Please know how to use your calculator for tomorrow for NCR, NPR, and we've taken class time to practice that. But in this one, wasn't there an and involved in the numerator? Is this one of those, you're picking 7 cards out of 108? The sample space, you're picking 7 out of 108, but the special condition was 2 wilds? So 2 wilds, 2 out of 8, but if you're picking a 7-card hand, that's only 2 out of 7. What's going on with the other 5? Oh, they're coming from the regular 100 cards. So 2 out of 8 were the 2 wilds, and 5, well, 5 must have been out of the rest. Simplifying down, it'd be 7.6% or 0.076. You guys will just have to look at the multiple choice as to whether they're giving decimals or percentages and just choose accordingly. Sound good? Letter B. This one, I think the 100 cards were split into 4 colors, right? And so they said, what if you get your 2 wilds, okay, 2 out of 8, and you get 2 of one color and 3 of another color. So that's how you got 2 out of 25, 3 out of a different 25, all over 7 out of 108. Once again, they did factorials. You have to use your calculator anyway. Why not use NCR? Number 52 had to do with a complement. Now, they use a different notation than I use. They use E prime or E apostrophe. I use the little tilde in front. Tilde, 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 tilde. I had it right. The little tilde in front. Either one means not, or the complement. And so we do 1 minus, which is easy, 64%, or 0.64. And then number 60 is the one we talked about yesterday. Both are available, neither are available. At least one is available. You do 1 minus neither, and you get the rest. All right, do we have any questions that we need to talk about in section 9.7 that you need further clarification on? Robbie? Which one? 44. Vico? 47? Okay, so let's start with number 4. Yeah.
60 plus C.
Okay, let's do the 40s first, and then we'll go to the 60s. If you guys don't need this, what could you be doing? Which is why I had the assignment up on the board, and you guys should have, smartboard, should have written it down when I had it up there for you. Okay, let's start with number 44, then moving to 40, it's on the next page, 7, and then moving to 61. Oh, 44 was down here somewhere? Oh, there he is. Gotcha. All right, number 44 gives us the deck of cards. Okay, the reason, Robbie, this one is confusing is because you have to think of everything that's going on, not just the words they're telling you. So when they say something like, a deck is made up of 108 and you're choosing a 7-card hand, you always have to keep in mind that you're choosing 7 cards, whatever they tell you. So check it. They told you what's the probability that a hand will contain exactly 2 wild cards. But you have to think, if there are 2 wilds there are also 5 non-wilds, 5 numbered. Does that make sense? And that's where a lot of people get confused. Now, the numerator would say, if you're picking cards, do you care which one comes first if you're just getting a group of 7? Does the order matter? Good. So combination, not permutation. Okay? So 2 wilds, I have to say, okay, I'm choosing 2 out of, how many wilds are there? 8. And times 5 numbered. Well, if 8 are wild, take away 8. How many are not wild? Got it. And that's where the other 5 are coming from. So this is saying 2 are wild, 5 are non-wild. And that's thinking about our 108 card deck. But in the denominator, it says, I don't know, whatever. Out of 108, how many different groupings of 7 are there? So these are the total, and these are the special. And so we divide the two, the sample space by the event. That was letter A. Letter B, and you know how to use your calculator, okay? You can just plug in NCR. Okay. Letter B says 2 wild, and 2 red, and 3 blue. So am I still picking, oh, sorry, 2 red. I'm still picking my hand, right, bud? So I can still have my, okay, how many total groups of 7 are there? But now I have to think about my special cases. So how do we get the 2 wild again? Like how many ways that's possible? And, okay, how many red cards are there total? Got it. So out of 25 red, you're only getting 2. And how many blue cards? We're getting 3. Plug and chug. Is that cool? So the crazy thing is they told you 2, but you have to think of, okay, so 5. And then the other one, just take it one piece at a time. And then number, oh, sorry, Johan. And not NPR? The dilemma is in this one, it didn't use the word group. Usually group is NCR. Like it's a group of whatever. It's a group. I don't care about how they're arranged. It's just a group. It has to do with my combo pizza. Like I don't care if the mushrooms go first and then the sausage, or the sausage and the mushroom. The permutations, there'd be 2 different ways of putting the toppings on. Combinations, it's one pizza. Who cares? This one doesn't say group, doesn't say combination, but it does say hand. And if you have a hand, if you like reorder 2 cards, it's the same hand. It'd be a different permutation, a different ordering, but it's the same hand. So in this one, a hand doesn't matter what order the cards are, you have what you have. And so this is kind of like the word group. So it's just one group, and I don't care how they're. Now, permutation would say, oh, you switch those 2 cards? It's different, like a batting order. Order is important because if 2 players are switched, it's a different order. But if you switch 2 cards. So if order isn't important, combination. If order is important, permutation. Yeah. I would use alpha y equals enter, get a nice pretty fraction, just to organize everything. Then I would go to math to go get your NCRs. Probability. Does it do weird NCR? No big deal. Just go before it. So the first. So you're going to put your first number for each one, then do your times. Is that cool? Is anybody else not? Yeah. I think yours is this thing. Let me see. So you would need to put your 8 before, and then your 2 after, like for the wild, the 8C2. And that will put the 8 in the end spot and the 2 in. And then you can just do times, keep going. And then you probably use it a lot as far as like parentheses with dividing. What other one do you have? I'll have to look it up. Thanks, Lauren. Yeah, I'll try to look it up. Yeah. Just says during. So it's up to you. If you still want to see homework questions, stick around. If not, you can go quick and then come back. Oh, sorry. there was also number 47. Is that right? 47 was over here somewhere. What's going on there? Oh, yeah, the defective. This wording gets tricky. Like number 60, that's why I went over number 60 yesterday, except this one added something in. It has exactly and at least. Oops. All right. This is kind of like how nasty 9.7 can get. We have 12 total. And then that's broken up into 3 defective, which means 9 are good, right? The vending company has ordered 4. And because each has identical packaging, the selection will be random. What is the probability that 4 units are good? Okay, that one's probably the easiest one. Okay, and they're not doing anything like telling us it's important what order you're opening them or anything like that. Like, it doesn't make a difference if the first one is good versus the second one being good versus the third. So this is a combination. You could say, how many different possible shipments of 4 could they have gotten from those microwave elements or microwave ovens? What are all the different groupings? Like, they could have gotten number 1 and 2 and 3 and 4, 2 and 3 and 4 and 5. They could have gotten how many different groups of those 12 microwave ovens are possible? And then saying, what if we got one of the 4 good? The card example. So you're getting 4 good out of 9. How many possible groupings is that out of the total probability? Letter B goes a little bit harder and says, okay, not all good, exactly 2 are good. Well, if 2 are good, what else does that mean? Yeah, do you see it? They got 4. So if 2 are good, 2 are bad. So how many ways could you get 2 good and 2 bad out of the total number of groupings of 4? And then let E, that's where it gets nasty. At least 2 are good. I'm going to go ahead and give myself more room on this one because let's first ask ourselves the question, is there less work to do to look at this as is or to look at its complement? This as is, at least 2 are good. 2 are good, 3 are good, or 4 are good? What's the complement of at least 2 being good? 1 is bad. No. Only 1 is good, right? 1 is good wouldn't work. Or none are good. 2 ways of doing it. One way would be counting up and saying, okay, what's true? And then the other way is going to be 1 minus what's false. So the way to count up, you would say 2 are good and 2 are bad. Or 3 are good and 1 is bad. Or 4 are good, right? And we're going to add those up. So we're going to have 9C2 times 3C2 all over 12C4 plus 3 good would be 9C3 times 3C1 all over 12C4 plus 4 good, 9C4 over 12C4. So we could add up and say, okay, it's all the possible cases. 2 are good, or 3 are good, or 4 are good. That would be at least, 2 are good. This way, well, either only 1 is good and 3 are bad, or none are good and 4 are bad. So we could just say 4 are bad, right? So if we were to add this one, wouldn't we get 9C1 times 3C3 all over 12C4 plus, what would that guy be? How do we get 4 bad, guys? Exactly. If you started trying out of 3, you're getting 4. Is that possible, out of 3 to get 4? Oh. There was only one way it wouldn't be true. So maybe complement would have been easier. But you kind of had to think about this one. Because if there were 4 bad ones, then it would have been possible for either 1 to be good or none to be good. But they were guaranteed at least 1 good one by buying 4 of them. And either way, Vico, this and this would be the exact same. This is saying add up the ways it's true. This one is saying how is it false? 1 minus that. Yeah. The last question I think was number 60 something. What was that one? 61? Didn't somebody have another question on 6? Oh, 60 part C. Super similar to what we just saw with Vico, in that there are 2 ways to do the at least type problem. Add up the ways it's true, or do 1 minus the ways it's false. So in this one, at least 1 vehicle is available. Whoa, that just, I don't know. Why are you being dumb again? Okay. Okay. I'm just going to close him for a second. We're going to open him back up. Nope. You need to reset. Are we kind of like that sometimes, guys? We just need a reset button. Just need to kind of walk it off, take a breath, take a nap, eat something. Okay. Let's see if it reset. It did. So what are the ways that this could be true? At least 1 is available. Both available. First one and second one. Or the first one's available and the second one's not. Or no, but none wouldn't fit that, right? Or the first one's not and the second one is. So either they're both available, or that the first one is, that one's not, or that one's not, that one is. That would be the way to add them all up. So in that case, we would go ahead and say, okay, either that's 0.90 squared, 0.9 times 0.9, or 0.90 times 0.10, available, not available, or not available, available. That would be one way. That's adding up all the ways it can be true, or we could do 1 minus. Well, what's not included? Either both are available, the first one is, the second one is, or none are. Yeah. So we could just say, well, the way this isn't true, the other probabilities that add up to 100%, what else is possible is that neither are available, which would be 1 minus 0.1 squared. But either way, adding up how it's true or taking away from 100% how it's false, you'll get the same answer. Second. All right, cool kids. Do you want some hints on the test tomorrow? Okay. If I were you, I would go somewhere in your test review or in your notes. Jason, go ahead and stand up so you can at least listen. Jason, stand up. Thank you. All right. Let's see. What are some hints about the test tomorrow? First of all, I have that you are allowed to use your graphing calculator the whole time. I'm giving hints about the test. Yeah? I'm giving hints about the test. Okay. You're allowed to use your calculator the whole time, but there are some blanks that you are going to have to fill in. What are some things that you should know? How to find the nth term, a sub n, for an arithmetic, or geometric sequence. How to find the nth term for an arithmetic or geometric sequence, or both. How to find the nth partial sum, s sub n, for the arithmetic or geometric sequence, or both. Are there formulas for that? Yes, 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 yes. Section 9.2 and 9.3, right? 9.1 was just an introduction. How to find the sum with a sigma However, if I say you're supposed to be using your calculator but showing work, with a sigma, is there a way just to throw it in your calculator for most of you? Yes. But if I say show work, what am I expecting you to do? Plug in 1, plug in 2, plug in 3, plug in however many you need, or plug in 3 and 4 and 5 and 6, or however many you need, or 7 or 8 and 9, however many you need, plugging in from the bottom to the top. But could you then go ahead and throw that math into your calculator? Yeah. So you could just add it all up in your calculator, or you could use the program. Hey guys, if I was to give you a sequence or a series and ask for the nth term formula, that was a little rough in homework. But wait, what if it was a multiple choice question? What could you do to all the a sub n formulas? Couldn't you plug in n is 1, n is 2, n is 3? Now wait, didn't we see in notes that sometimes you could plug in 1 and 2 and get the same thing from multiple formulas? So should you plug in a few of them to make sure they all match? Yeah. But maybe if it's a multiple choice, you can work backwards. Study in section 9.3, infinite geometric series. If r is greater than or equal to 1, it's the absolute value of r, meaning 1 or negative 1. If it's bigger than, if it's outside, it's going to 2, 3, 4, 5, or negative 2, negative 3, negative 4, negative 5. Will the infinite sum exist? No, because the series will diverge, aka the sum is undefined. But what if r is in between 1 and negative 1? Does the sum exist? Yes. Is there a formula? Yes. Do you have to show the little limit as n goes to infinity? No. At the end of the day, all you need is a sub 1 all over 1 minus r. But that only works if r is what? Within 1 and negative 1. So if I tell you to do something on a question like NCR or NPR, can you use your calculator? Yes. But what if I have a blank to the side and I say factorial formula? You're going to show me the formula. You don't have to use it to solve, but you have to show me the formula properly to get all the points. Hey, is there something in section 9.5 called the binomial theorem? That could be important. Like maybe how to find a certain term. Oh, could you maybe do Pascal's triangle and like write out the entire whole thing and then find the one that you need? Yes, but what's easier? Remember Kathleen taking her work up to the webcam? There's a formula that you can, instead of doing all of Pascal's and writing it all out, can't you jump to where you want to go? Make sure you study that. Oh, wait a minute. What if there are numbers in your A's and your B's? Can you just get the Pascal number, or do you have to like show the whole term? Maybe you have to be squaring or cubing or fourth powering some sort of coefficient at the same time as doing your NCR. Then there are going to be ones on section 9.6 and 9.7. Guys, if the question says how many ways, what section are you in? 9.6, you're looking for counting up how many ways something can be true. If you are talking about choosing candidates for offices like president, vice president, secretary, treasurer, does order matter or does order not matter? Ooh. Because if it says how many different ways can the positions be filled, if one guy's president in one order, but he's vice president in another order, isn't that a different way of filling the offices? Okay. But what if I say something like picking a committee? Just a committee, no position, just a committee. What would that be? NCR, combinations, the difference between order mattering, order not mattering. What if I say something where there are multiple options, kind of like our deck of cards, kind of like our, what was the other example you guys just talked, the microwave ovens? What operation do you put in between if something needs to be true and something else needs to be true and something else needs to be true? Multiplication, but what if it's an or? Addition, but what do we have to be careful of with ors? If we just add together how many ways this can be true and how many ways that can be true, what could have happened? So I have to subtract overlap if it occurs. If I'm talking, just for you guys to know, if I'm talking about how many ways of picking classes, does it matter if you pick your Calculus AB class for next year first and then your AP Chem, or your AP Chem first and then your AP Calc? Some of you are like, who's doing that? Not me. Anyway, but does it matter, or is it the same course schedule? Okay, so order doesn't matter when picking classes as far as which one you choose first or second. Oh, what if I give you letters and I ask about different ways of ordering letters? What do you have to make sure you be careful of? Are any of them repeated? Ooh, repeated. What do we do with repeats? Complementary events, that might be helpful. Something to do with picking out things that are different colors, whether they're cards, whether they're marbles, whether they're pieces of paper. I don't know. And yeah, that's good. Hold on. Pause. That was all multiple choice. Long answer. Long answer. Something to do with an arithmetic sequence. I give you some clues and I ask for some information from the clues. This is one of those, I don't give you the whole sequence. I give you maybe a couple terms and I ask you to analyze. Another one is I give you a series in a summation, a sigma notation, and I ask you to tell me all about it. What are the first few terms? What's its first term? What's its common ratio? What's the S sub n formula? What's the particular S sub n? You could not just use your calculator to fill in those blanks. And then last but not least, I give you a binomial to insert whatever you need. Pascal's triangle, the binomial theorem to expand, simplify, and give me that thing. And simplify. A bonus might have something to do with the repeating decimal. What? All right, cool kids, we're done. The bonus might have something to do with the repeating decimal. All right, we're done. Grab a seat, Jason. What can you do for the next 15 minutes of class? Whoo! Review, work together, ask questions. If you need to move around the room to work with someone who will keep you awake, alert, on top of things, do so. If your group is good enough, do so, but do not waste this time. Man, I was nice on those hints. What? Yeah.